Hello everybody, I am Satish Kache and this is Shivam Borade. We are the team leads for the project titled Design and Fabrication of India's Largest Electric Unmanned Aircraft. So, both of us were in our third year of engineering when we got this idea to build India's largest aircraft. It was very ambitious. So, what's the first step for any initiative? It is the design phase. So, in the design phase of this, we applied the course curriculum that was taught to us in our third and fourth year: aerodynamics, flight mechanics, stability and control. We made a theoretical design report of 200 pages. Now all of this design report needs some validation, and hence wind tunnel testing was done on this exact model to validate this design report. And this happens to be our BTech final year project. We finished our BTech in the year 2023, last year. So once the design was completed, we approached our university asking them for funds to actually build the big aircraft. But then they asked us to build a smaller aircraft before we can proceed to the bigger one. And hence we moved into the prototyping phase. In the prototyping phase, we got 2 lakh rupees from the university. We took 2 months. It started in April 2023. We took 2 months to complete it, and we finally made this aircraft. This that you can see here is 1:3 scaled down version of the bigger aircraft. It was 15 kgs in weight and wingspan was 3 meters. We flew this successfully in Hadapsar Gliding Center here in Pune. This is a small video clip of the prototype. As you can see, the aircraft performed really well. It had a very short takeoff, and performance-wise, we used Pixopt 6C flight controller to record the flight data, and we validated the flight data to the design, and it was almost perfect.
Increase the throttle. Increase the throttle.
That you can see was a perfect butter landing. Now after this, we approached our university asking for more funds. Yes, we have proven our design, we have proven that it can fly. Then our university granted us 20 lakh rupees to build the bigger aircraft. Then what did we do with those 20 lakhs? That brings us to phase 1 of this project. In phase 1, we took 10 months and fabricated the whole aircraft from scratch. It was started in July of 2023. And till May of this year, 2024, we were fabricating the aircraft. There were a lot of industry experts involved as well. A few are Wing Commander Tarun sir, Ryan Pinto sir, and Dr. Joshi sir, who holds the current record for the largest aircraft, electric. Then rigorous tests were also performed, which were bending tests. As you can see, this is a spar, and we actually performed destructive testing on it to match the simulations. Impact test, what if there's a bird strike on that big aircraft? And then we tested our servos for the load as well. This is a 60 kg centimeter servo. We actually hung weights and tested it. At the end of phase 1, we finally were able to make this aircraft with an all-up weight of 250 kgs, wingspan of 9 meters, an endurance of 10 minutes, payload capacity is 100 kgs, cruise speed is 60 km per hour, and maximum speed is 120 km per hour. These are some primary specifications of this aircraft. And once this was built, we conducted some taxi tests at our university. This is our ground, and as you can see, the aircraft structural integrity was perfect. Like, it was ready to fly. Then we took it for flying, and this is the flight video. That is 250 kgs in the air. And the aircraft performed a hard landing after that. So in spite of performing all these tests and being so sure, where did we go wrong? And that brings us to the thrust of these motors. The way our motors are configured is something like this. There are two motors in the front and one motor in the rear. So the prop wash of these two motors was directly hitting the third motor, because of which the third motor's thrust was almost only 20% of its full thrust. So if this was 10, 10 and 10 kg thrust individually, they were only producing 10, 10 and 2 kgs. So that led to an overall thrust loss in the first attempt. But we did not give up. We moved into phase 2 and we thought, let's fly this plane. So in phase 2, we started it in June of this year and it spanned for 3 months, June, July and August. And we have done some design modifications. Number one, in the last slide when I explained what went wrong with this, the prop wash of these two motors was hitting the third motor. Now what we have done is increase the distance between these two motors so that the prop wash doesn't hit the third motor. So we have an increased thrust. But we also wanted to reduce the weight of the aircraft. And in order to do that, now this is a perfectly balanced CG. And to reduce the weight, we took away 50 kgs from the nose, the ballast that we added. But because we took away, now the aircraft is tailhead. To counteract this, we pushed the tail of the aircraft forward and closer to the wing. Now, if you see, the CG is perfectly balanced. So all of these three changes together, increasing the distance, increase the thrust, reducing the weight and perfectly balanced CG. So because of this, we went ahead with phase 2 trials, and this is the video of what happened in phase 2. This is the aircraft. It's rolling down the runway. It is struggling to climb and it couldn't leave the ground. It was not airborne. And it crashed at the end of the runway. This is exactly what happened. And the whole team was dejected, but we didn't give up. We really don't want to give up on this aircraft. And that brings us to phase 3. In phase 3, what are we going to do? Number one is we're reverting back to the initial design. Whatever design changes I mentioned, we're not doing that because in the first attempt, at least the aircraft was airborne. It was flight worthy. Second thing, the only problem during the first attempt was thrust and power. So this time we're increasing the power by changing the propulsion system. The third one, there'll be a better runway, a proper tarmac to fly this. And the fourth one is now there's an active steering system. We've increased the structural strength of the fuselage and the flight controller firmware. We're also using a different firmware and we updated a lot of parameters. And all of this brings us to this aircraft. The aircraft is right now standing here in MIT ADT campus and it's ready for takeoff. But there is one problem. This does not have a propulsion system. So, as a team member, as a captain of this team, we are asking your suggestions into what propulsion system can be used for this huge an aircraft. We need your suggestions and guidance to take this project forward. So the minimum power requirement for the propulsion system is 40 kilowatts and minimum thrust required is 180 kgs. If there is any propulsion system satisfying both of these, be it single motor, 2 motor, 3 motor, 4 motor, we need your suggestions and we can incorporate them and together we can make this aircraft fly. Thank you.